okay? And what's funny is you have in this universe, they say that we can see, 10 to the 80th atoms, okay? That's all the atoms that we can see in our entire universe, right? Our observable universe. 10 to the 80th power. Do you know how many permutations they say that they can find, how many mathematical constructs that they can use for these higher planes? 10 to the 500th. This number is so big that you might as well say it's infinity. And if there's an infinity of anything, right, like an infinity of mathematical constructs, just by the the laws of statistics and probability, if you have an infinitive number of mathematical constructs, you're going to find one that lines up with your physics. That doesn't make it true, though. It just makes it statistically impossible not to find a mathematical construct that lines up, because there's an infinitive number of them. That's just an idiotic. I can't even. Man. Anyways, so they're going to go through every one of these permutations, every one of these mathematical constructs, and they don't care. If they have to say there's 10 million trillion higher to planes, they're going to say it. They don't. It could be unlimited according to them. But if they lie about the first, second dimension, and they lie about the fourth dimension, why would you continue on? So not all mathematical constructs are true. Some are, but most just are a math representation of what's going on. So it's easier to visualize it. It's easier to do the math. It doesn't make it true. Okay. Length contraction is fake. I already went into that. You can't contract an adjective. Okay. All time dilation can be, all relativity. It can all be explained with time dilation. Okay. So the thing is, the whole thing is speed goes 186,000 miles per second. Okay. So to explain this, right, you can either do it with distance, length contraction, or you can do it with time dilation. Okay. Why can you do it with both of them? Because speed is length or distance per time, right? So you can either make the the length contract, right? Or you make the time dilate. Time dilating means you stretch it out, right? So you can explain it either way. You can throw away time dilation and explain everything with length contraction, or you can throw that away and throw it and tell it mathematically. Mathematically, both things are true, okay? But what's true in real life? They're both true because they're mathematical. The mathematical constructs are not true. Okay. Okay. So you have one time dilation can explain it all, and it's common sense, man. It's obviously. It's like I can explain it to a 3-year-old in like 3 minutes. But length contraction, okay, it can explain it too. But first of all, length is an adjective. Okay, so you can't contract an adjective because an adjective is a word. It's not a thing. It's a word that describes. Okay, and then also, right, you have to use magic. This idea that we all live in our own universe, I guess, and some lengths are contract for other people. The whole universe. Like I'm traveling to a star, and in between me and the star, it just contracted, huh? But just in my universe, huh? No, it's just your perception contracted, man. Just like this. Look how the length going up and down. Look how good now the length gets contracted. But that's just a mathematical construct. It's just your perception. It's just your frame of reference can't see the whole length. Doesn't mean the length disappeared. It's still there. You just can't see it from your frame of reference. Like, do these people, like when I go like, when I do this and I say, hey, look at this length going up and down to these woke people, and I go like this and I say, oh, what's the length? And they're like, oh my God, the length shrunk. Do they really think that the pack shrunk? Because that's what they're saying. I can't. My brain isn't smart enough to say, oh, you just rotated it and my vision got smaller. I can't see the side. The length is good now. That would be the, no, I seriously, do they think this, when this happens, that the length literally contracts? Or do they know that, no, it's just your perspective. Your frame of reference is showing you less length. Like, the length didn't actually contract, okay? Your perception contracted. Your vision contracted. Okay. So anyways, let's get on to the next one. Light travels through a vacuum at 186,000 miles per second. Okay. And I know Einstein said, oh, that's only in an inertial frame. Hey, screw Einstein. Okay. Light travels through a vacuum at 186,000 miles per second. Okay. I don't give a crap if you're accelerating. I don't give a crap if you're in a gravitational field. I don't give a crap if you're in an inertial frame, an accelerated frame. I don't give a crap. I don't care if you're in a spinny thing, spinning around, you're orbiting, whatever the hell you're doing. Okay? There is no frame that exists. Okay? Alright? Where light is not moving at 186,000 miles per second. Okay? There is none. Okay? Don't be listening to that Einstein, okay? He's an idiot. This is every frame. Accelerated frame, inertial frame, I don't give a crap, okay? Light travels 186,000 miles per second relative, okay, to space-time. Only one thing causes time dilation, okay? They keep saying, going in another dimension and this and that. Okay. Look, when you're standing still, you have a light clock like this, okay? It only has that little distance that it has to go through, right? You're standing still, that is you, okay? When you're moving, this photon comes down, hits this plate. Now, instead of going back up and just doing this little distance here, it has to go all the way up there because you moved. The top plate moved over to here. You threw out your photon, but as soon as you threw it out, you're moving. Now it's over here. So you can see this is a longer line, right? Now, if light moves at 186,000 miles per second, no matter what, right? And all information is transmitted through, and all physics, all accelerations, all physics, all everything is done by atoms throwing photons to each other, synapses throwing photons to each other, everything. So if all the information, see, this is your time dilation. If this line is twice as long as this line, then you've been time dilated twice. See, the thing is, from here to here is a specific unit of time. Let's just say it's a second, okay? Obviously, it's not a second because a photon would be like a billionth of a second. But let's just say that's a second, or whatever unit of time, right? Now, this guy that's moving, see this from here to here? That's a second. That's what time is. Time is the length of this line, right? Right? Here it's a second. And if you go faster, if this plate would have been over here, right? So this line, this diagonal line, went all the way to here. Yeah, that would be a second still. Okay, it doesn't matter how long you make this line. Once it goes from one plate to the other plate, it is a second. Okay, if it takes if you have a long line, you have to go the same speed. You're going to take longer to do this than you do this, right? So you're slowing down information. You're not slowing down time. You're just so. Next thing, there are two gravity fields. Okay, this is an important postulate. Okay, one field, right, is fake, and one field is real. Okay, now the gravity field that they talk about, these woke podcasters and that, their fake gravity field pulls down objects and accelerates them down to the ground. Okay, of course, they stay inertial the entire time, so how are they being accelerated? I don't know. They won't tell me. Okay, that's the real gravity field pulls down space-time itself. So when that ball is falling, say that falling object, okay, it is not falling, it's floating relative to space-time. Yes, relative to Earth, the falling object is accelerating to Earth. But that's a relative thing, okay? When two paths just happen to, pass each other, cross each other, and their paths are accelerating towards each other, but you didn't put any force on any of the objects, that's a relative acceleration. The two objects stay inertial, you know what I mean? So what they're saying makes no sense, okay? What I'm saying is, gravity pulls down space-time, right? It's the thing that gets accelerated, right? It's the thing that has force put on it, right? The ball or the falling object, it appears like it, but it's just floating there. The spatial coordinates, think about it. If the spatial coordinates move and fall and accelerate down, if you're falling and accelerating with it, and you're keeping your same spatial coordinates the whole time, then, see, that's what people don't understand. This ain't, standing still means, we say relative standing still. There is a real standing still, okay? It's standing still relative to space-time, okay? And if you stand still relative to space-time, you will have a clock like this, a proton clock like this down there. I don't know if you can see. See there? Where it just goes straight up and down, okay? We don't have that kind of clock, okay? We have a relative standing still clock. And it does this, right? Let's go on to the next postulate. No time dilation in inertial frames other than from velocity. All right. You don't. If you're in an inertial frame and you're falling in a gravitational field, there is no time dilation because you are moving at a constant velocity in a straight path. Okay. That means you're inertial. That means there's no time dilation. Okay. So if you're falling and you're in a gravitational field, you're in an inertial frame, man. If you have an accelerometer, it'll tell you that you're inertial. Okay, no force is being put on you. Okay, you are not being time dilated in any way, shape, or form. Okay, the man on the Earth, he's going to be time dilated. Yeah, of course. He's touching the gravity machine. He's touching the Earth. The falling man isn't touching the Earth. See, the equivalence principle only for being in a gravitational field, it only matters if you're touching the gravity field. If you're touching the rocket ship, if you're touching the spinny thing that you're in that spins, if you're touching the Earth or a planet, if you touch the gravity machine, then you are now in an accelerated frame of reference. Okay, and then you will get time dilated, right? But when you're falling, you're not getting time dilated. That's bull. And I'm going to go back to this one. That's another postulate. Okay, my postulate says there is a standing still. Okay, it's just a mathematical construct, though. We can't actually get there, right? I mean, if we spend 1 million years and all humans were just add this one thing focused on to getting to this standing still, yeah, sure, we can do it sooner or later. Yeah, but no, we ain't ever going to do it. Okay, because you got to leave the plane of the galaxy to stand still, right? So standing still is this, okay? Relative standing still is this. Everyone in the universe is moving, right? You can't stop because who would stop you? How would you stop? What are you going to grab onto? Everything's just floating through space, okay? So to think that anyone in this universe has this clock is insane. You're insane, okay? And so this leads to the next postulate, right? When you're talking about like the twin paradox, right? You're going to another star, right? When you go to another star, okay, and you come back, you'll be time dilated one way, and then when you come back, you'll be time dilated in the opposite way, so they cancel each other out, okay? Because you have a clock like this. So when you're talking about twin paradox, you are directional. Your time dilation is dependent on your direction, right? Because if your clock looks like this, that means you're moving to the right, right? So if you move to the left, you'll have your thing go back up, so it's kind of straight and up and down, right? You will speed up time, right? But what if he goes even more faster in the same direction he's going? Oh, then this line gets bigger, right? And he'll get time dilated more. It's direction dependent.